I think we can start because it's 3 and the others will join later. So hello everyone, very happy to be here for the last day of the CGE training. And as you know, today Tuhemi and Dorothée will be presenting the microsimulation part. So just a recap of what we have seen so far, we started the first day with the macro and micro tools that we need to build a CGE model, from the producer theory to the consumer theory, how to read and interpret the social accounting matrix. Then we started with the simple model, how we can write it on GAMS, how we can run simulations, and how we can interpret the results. Then we have seen how to introduce the rest of the world, especially the theory behind the constant elasticity of transformation, the constant elasticity of substitution, and what data do we need to build an open economy CGE model. Then we wrote this model on GAMS. We have seen how to interpret the results. Finally, we have seen also an introduction to the dynamic models very quickly, especially the recursive ones, with a special focus on two main concepts, the business as usual and the balanced growth path. What data do we need for dynamic models, and the importance of dynamic models compared to static ones. Today, we will go back to the static models, but see the microeconomic dimension of static models, in the sense that in general, CGE models are accused of being too simplistic, in the sense that they represent the macroeconomic effect at the country level without going into the details of what's going on at the micro level. So what Tuhemi will be presenting now is the microsimulation, where we can really examine the impact of a macro shock at the micro level. So this will be very useful for all of us, especially if you're working on microeconomic topics. And I will stop here. Thank you, Tuhemi and Dorothée, and over to you.
Thank you, Shahir. Can you hear me?
Yes.
Thank you. So yes, I am with Dorothée. We're preparing the introduction to CGE model from the microsimulation approach. I hope we will be successful to present this concept. So why we are looking for that? Because we want, in some simulation or shocks, we want to look what is the situation on the impact in a distributive level. Distributive level, it can be generally on households, but it can be in other statistical units like firms or order. Yes, when we are speaking on microsimulation, it's not necessarily only on the CGE model. I will come back on this point. It can be with other models than the CGE model. But in our training here, we are looking only on the link between the CGE, macro or sectoral CGE model, and microsimulations. But in general, we can do some microsimulation within the other context or modelization. So we approaches that we want to look the link between macro CGE model and microsimulation modeling, and we look the link between the two. Why? It's to analyze the distributional effect of economic policy shocks when exogenous come from the CGE model. The shock is coming. We can have some models where we have a shock on macro level, like the model presented yesterday by Shahir, or other model to look to see what is the situation for agent, for individual agent. As I told before, it can be households, individual companies, or others. So, two main family of questions. Some of there is a parametric and the other is non-parametric, because when we are doing microsimulation approaches, it's we use a statistical concept and econometric concept. It's not only aggregated level, so we need to use statistics or econometrics level, particularly the poverty analysis and inequality analysis. So when we are doing microsimulation, we need all of these. So CGMS for microsimulation, CGE microsimulation models capture both the macro sectoral level. We can reconstruct the macro situation or the macro result, macro and sectorial results from the micro simulation approach by aggregation from in the CGE model, and also micro-distributive, the impact on household. And with this approach, we can capture all the heterogeneity between individuals. So we can see the link between when there is a shock, what is the link between the macro situation and the macro level. It can be used. I hope some of you will be interested to use the Microsimulation CGE model when we are looking for the public policy spending, taxation, trade liberalization, labor market, external shock, world price variation, crises, etc. Here it's from PEP. It's an illustration of what it means. Microsimulation approach. In this, you are see here, we have the micro level situation where the model is here. We have the production, agents, wage, commodity price. If you want, you can see this like a CGE model. And we have here a shock coming from a reform or an external shock, in any external shock that we can simulate from a CGE model. But after that, we have in the other side, we have the micro data, a micro level where we have income, consumption, particularly for households, and from income it's coming from labor markets. And we want to see what is the situation on poverty income distribution on some indicator like consumption or expenditure, per capita expenditure in households. But the link is important to see here, the intermediate transition from the macro level to the micro level. It can be in the two sides. It's from wages and from price, because wages influence, it determines income, and it can be also capital, and there is commodity price that it impact consumption. So we have the link, that the courroie de transmission in French, to go from the macro level to the micro level. There is many approaches into the last 2 decades on producing microsimulation approaches. Here we have a review of this approach. It's important to see there is many, and each methods here listed here has advantage but also limits. The first one is that one used frequently by some researcher, when we group the households in a limited heterogeneity. If you construct from the data, you have a sum, and you construct the model with 5 categories of model, from decile or quantile or quartile, or by residence, urban area, rural area, or any stratification, but in a limited groups. This is one possibility. But of course, if we construct a model with a limited heterogeneity, we can capture the impact on each group, but we cannot capture the heterogeneity intra-group, in each group. The second category of model is fully integrated households. In this situation, we go behind the limited groups, and we integrate in a CGE model, inside the CGE model, all the household in the survey. This is exactly what I will illustrate in the second part of this session today. I construct for this training with Dorothy, we construct a full integrated households model from external model that presented by Shahir yesterday, and we construct step by step. I will help you to understand exactly how to conduct the full integrated households model. Maybe it's one of the more complicated approach, is the complicated approach, but it needs more aspects on modeling, but less in econometric approach. But it is one, I think, one important households microsimulation CG approach. There is the top-down micro-accounting approach. In this situation, it's like the one after, is micro accounting. There is no behavioral response because it's top down. We have the shock from the top of the model. If the macro model, this is the top, or the CGE model, like that one we examined yesterday with Shahir, and we are looking what is the impact of a shock, of a simulation from the top of the model on the CGE level, in the global or sectorial level, macro model, and we see what is the consequence on the micro level. But in this situation, it is not integrated. It's only a transmission of shocks on variables in the household one. There is no response, and is generally accounting is different. In the second, limited because we don't estimate any parameter in this situation. To go behind this one, or in the researcher develop a top-down, but with behavior. So in this situation, we have to estimate how the behavior of households, of the statistical unit we consider, to look what is the situation when there is a shock, how the labor market, how the consumption of goods react for this situation. So it's more interesting than accounting matrix, but it is more exigent, more we need more econometrics approach to look on that. The fifth one is bottom up with behavior. In this one, we have top down. In this, we have a bottom up relation. What it means? Generally, in the first methods or approach, we are looking from the top to down. In this situation is the inverse. We are looking what is the reaction of the model if there is a shock coming from the bottom of the economy. I can give you an example. Suppose there is an impact that the government changed, I don't know, allowance for family. So it's a direct one, but we are looking what is the reaction of households because they receive more revenue, and we want to see what is the impact of this measure, of this policy to all the economy. It's the shock is in as written here, shock first applied in a microsimulation block, and we are looking for the bottom model to see what is the relation between the two from the bottom up and go to the CGE one on the macro and sectoral. The last one is top down and bottom up with iterative feedbacks. With a loop, we are looking the impact. We can start the top level to the bottom and go from the bottom to the up of the economy. This is what we have as approaches in microsimulation approach. So now, if we have to see, if you want to look for a literature, you can see there is many literature on this concept. It's a households group. It's one approach. You can see in De Jonvry, Shia, Wahba, Ducalier, Patrice Savard, and Torbeki, and others. There is many literature on households when we are grouping the households in a group, 10, war, etc. But in this, as I said before, there is no redistribution within the group because the number of group is fixed by hypothesis. It's a real limitation, limited by behavioral assumption that introduce heterogeneity between households, but it is easy to apply. It does not, in a numerical aspect, is very easy. It's the first step. Now, the fully integrated households is more interesting. It's introduced by our colleague from the PEP network and others from the DIAL, network. It's a network. Or, it's by the Oui, Chahir, c'est
C'est un centre de recherche.
centre de
Research
recherche
Center.
rattaché à Paris 1, c'est ça? À
Yes.
plusieurs universités. C'est Denis Cognot et Anne-Sophie Robillard and others. And the other authors, it's from the PEP. So in the full integrated households, it's limited by behavioral assumption that introduce heterogeneity between households. But the challenge in this, it is exactly what we will see in the second part, is how to be sure that data reconciliation. This is the great challenge when we are doing the full integrated, is to be sure the reconciliation between the microdata and the macrodata. The microdata is generally from a survey, and the macrodata, the microdata, is coming from a sub generally. And the more interesting approach is the cross-entropy approach. And exactly this approach I will present briefly in the second part. So why we cannot use, if it is very interesting, that often lack of complete information, it is more difficult to access to data needed to construct a full integrated approach, and we need to weight the households in the model by extrapolation in this. The numerical resolution can be challenging depending on the behavior assumption. But when you have a good software and a good solver, if you have the license, you need a good solver to do that. It can be done. The extrapolation of the representative household behavior to enter in intergroup, and we can conduct many distributional analysis in this situation. We will see that is interesting. Top-down approach. In this situation, it consists in taking price or labor demand from the CGE model. We solve in the first time, we solve the macro model. And after that, we take only the variation of price and income, salaries. And after that, we go and we look of that. Just, Dorothy, you have the linkage here. We have the CGE model at the top level, and we have the microsimulation module here down. The exogenous for the endogenous for the CGE model is consumption, price, and other variables. All other variables we can consider, and we have exogenous labor supply and other characteristic and parameterization. So when we have a shock in the CGE model here, in the top level, there is a variation, as we Shahir explained yesterday. We have the price change, the capital, rendement du capital, rent, the return of capital, salaries, labor demand, and with this variation, we got a microsimulation model. What is endogenous for each household is his income, the consumption, and his labor supply. These variables are here somewhere. This is the link. And the exogenous for each household is the variation of price and price of factor as here. So we are looking at the impact here, and we can do any distributional analysis after that. But we are coming from the top to down. This is what it means, top down. Top down with no behavior is a micro accounting. This is what I told you before, is a very simple approach, no feedbacks. From the top to the down of the model, no feedback effects, no adjustment by households. But generally, this approach is overestimate the effect because is like you suppose the elasticity equals zero, but there is a loss of information because we consider a fixed behavior, and generally there is an incoherence between the two parts of the model. We have no need to extrapolate, etc. It's one approach. the other approach I presented before is top-down with behavior, with some behavior. This is where we need more econometrics. It's more rich behavior because we estimate all the behavior for households in the labor part and in the consumption part. Why we have to look for that? Because it's supposed that household change their behavior after the shock. But the application is more complex and require more econometric modeling. I think for when we are debutant, where we are just starting research in that, we cannot recommend to start by this, because you need to understand CGE modeling and econometric approaches. So, and econometric approaches here is generally a microeconometric approaches. So it's more difficult, but you have to see the exist. We use aggregate functions in the CGE model, but we have a microeconomic behavior in the down of the model. Just to give you an illustration also here, what we have here is a bottom. Sorry. So is the second approach here, or another approach is bottom-up situation. What is the story? Look, the difference between the two models is in the middle here. We are looking for the shock is coming from the bottom of the model, and there is a shock probably on price. It can be also on some subsidies from the government, or not on price, on income. And with this shock, it can be simulated in a general level or at sectorial level like this. This is another approach we can use. There is many examples we can see in the literature. If you put in your browser only, I don't know, Microsimulation, you will have many literature and use and program here. I will return of that and give you some example. Do you have any question from this introduction, at least for now? Is there any question in that general framework?
Yes, I have one small question.
Yes.
When you talk about the econometric modeling, etc., inside the model or beside it, and then we integrate the results in the CGE or something like that?
Yes, no, it's outside the model. We are in top-down approach, and we modelize the behavior of households. It is outside the model. We construct the model, the CGE model. We introduce the shock, the policy we want to analyze in our approach, and after that we do the econometric approach on the data, on the household data, and all econometrics we have to do is in the data. There is no we have to not to go to return to the model. No, we are looking. Just I give you an example. Suppose there is a shock in the labor market, and we simulate that at the macro level or sectorial level. After that, there is a variation of salaries, and I don't know, is unemployment, if you have an unemployment rate in the model, and in the income. We take the variation from there, and we look in the survey, what is the reaction of all households? What it means, the reaction? It can be on labor supply for the households. It can be how to change to consume some goods because the price changes, etc. But we are doing that econometrically outside the model. Okay, Ali.
Thank you, Mr. Tiami. Just one question.
Yes, Ali.
Under my understanding, just
yes.
when we simulate suppose what we have reform, and this reform is at macro level. But
Yes.
if we simulate this reform at the macro level, so we suppose that it's exogenous, but
Yes.
in reality it's not exogenous. It's endogenous because it depends on other variables at the micro level. So is it preferable to do the simulation at the macro level or at the micro level?
Ali, to be more clear, give me what
Yes.
you have in mind, and I will.
For example,
but
if we suppose that we are working on the substitution reform. Substitution reform, for example, we take the example of Algeria because we have.
subsidies, c'est les subventions, tu veux dire?
Oui, les subventions. Si on veut réformer, par exemple, les subventions.
Ouais.
Les subventions, donc, c'est généralement sont dans les prix.
Bon,
Mais
c'est
par
exogène,
exemple,
pas
c'est...
extérieur.
Voilà. Donc, si on prend, par exemple, cette simulation au niveau macro, c'est-à-dire qu'on prend le secteur de l'industrie, c'est-à-dire l'industrie de l'énergie, et on va simuler cette réforme. C'est-à-dire, mais le problème, c'est que l'hypothèse forte qu'on fait, c'est l'hypothèse qu'on dit que cette équation, c'est-à-dire à tel macro, elle est exogène. Alors qu'en réalité, elle n'est pas exogène. Donc, elle est
Non, attends, Ali. Non, attends, il faut être clair. Pour simuler ce que tu dis, I am sorry for who
okay, we
speaking, but if we simulate what you propose, Ali, generally is a questionable for a CGE model in a general aspect. We suppose that fixed exogenous variable that support when we are doing simulation in a CGE model. This is exactly the last point yesterday Shahir on phases. Shahir tells you yesterday when we introduce a simulation, we are looking for variable with fx. So the simulation in a CGE model is in microsimulation and other, we have to introduce the shock only on supposed exogenous variable. It can be really supposed. Yes, but this is not a microsimulation problem. This is a modeling, a CGE modeling question. I know generally, really, it's exogenous. I give you an example. I don't know what's the situation in Algeria. If the government decide to reduce the subvention of carburant, just to suppose, yes, so it's exogenous approach, right? It's exogenous because it's a policy recommendation. The government reduce the subsidy of some goods. We have the same situation in Morocco or in Egypt. We can't support, but this intervention is an exogenous one. I give you another example. This one is clear. Suppose the price of export, international price of export for oil from Algeria, gas or oil from Algeria, going up or going down. What is the consequence on poverty in Algeria? You see, we have to simulate that in the macro sectorial level, and we want to see what is the consequence on the poverty. We can do that by one or order from these approaches. We can do it in a top-down situation or full integrated, and we will see the result we have. I don't know it's clear for you, Ali, much.
Yes, it's clear. Just so I would like to say that it's more preferable to do the simulation, so to do the reform at the micro level compared to the macro.
The first step, the answer is clear. You must simulate the shock in the macro level and to see the consequences in the micro level. It's clear. The answer is clear. Shahir.
Perhaps just to add to what Tuhami said, Ali, I think given that we are not reasoning in terms of applied microeconometric tools, what matters for us is what's going on at the macro level. So at the end of the day, it's a macro shock, a tariff shock, a tax shock. And what we're trying to see is what is the heterogeneous effect of this macro shock, but at the micro level. So that's why the simulation does not take place at the micro level. It takes place at the macro level.
Yes.
Yes.
Okay. Okay. The aggregation, I will go on. Quick questions. Generally, there is many questions where we are doing the micro simulation approaches. There is many questions which approach we have to use. It's correct, but there is, I think, in the conclusion I have here, we prepared here, there is. The tools can be used simultaneously if we can to create the same question, but it depends on what you have, on what you need exactly, which answer you are looking for, what data do you have, what computers do we have, what is your knowledge about econometrics, what your knowledge on developing full integrated in CG modeling. It depends on many other things. But in a theoretical level, there is one word to be very careful in economics. If you know the Dayton and Mulbauer book on the consumer behavior, it's difficult to see what is the aggregate situation. I give you just a small question. You are a researcher, and to see if you have a utility function for households, and you have, I don't know, 10 households, and I tell you we have a Cook-Douglas utility function for each of these households. We have a Cook-Douglas utility function for each household. What is, if I have to aggregate, what is the utility function for the representative household of the 10 households? It cannot be a Cook-Douglas. The aggregation is very difficult. Generally, we are looking for the what we tell the Engel relation. We are looking for the relation between I don't know, food expenditure with the total expenditure or income in general, and we are looking for the Engel curve. But you are looking for Engel curve for each household or group of households. We cannot aggregate and found the same relation in the aggregated level. So many questions, many theoretical questions are here. What we have no time to go there to say exactly what we do. It's an interesting question. We're looking in a micro level also on the households level. There is many paper, theoretical paper by Heckman, Roster, and Tabor, looking what is the situation, particularly from the labor market perspective. When there is a shock, what is the consequence on the labor market level? And how can we see the impact on the aggregation of reaction from household to the macro level? There is many interesting questions at this level. But I think we have no time to go. Just we will send you this presentation if you want to go and to see the aspect we introduce here. So that's what we know is the aggregation problem. Given this restrictive condition, there will be an aggregation error between a CGE model and the aggregated result of microsimulation if we do this separately. Top-down and bottom-up approach was designed to capture also the feedback between the two to overcome just particularly the inconsistency between the reactions. This is for top-down and bottom-up. Is the last one I present for you. It's I think one of seminal paper produced by our colleague Luc Savard, who is the co-author with the book presented yesterday by Shahir. Luc is our colleague here. It was our colleague here in the faculty, and in his thesis, I think, with Bourguignon, they are working on a top-down and bottom-up approach, microsimulation approach from a CGE perspective, and application for the Philippines. And they are looking what is the impact of a shock on the CGE model. What is the consequence on the bottom, on the household, and after the reaction of the household, there is a feedback to go to the national or sectoral situation and iterate. It's very interesting loop. We are looking at the shock. Ali, the shock in this situation is in a macro level, in a sectorial level or macroeconomic level, and after that in the microeconomic level. This is what we have here. Before, we have looking only from the CGE model to the households model, or from the household model to the CGE model. And in the situation, it's coming from the macro level, from the households level. And after that, we look the results here on the CGE model after the reaction of the households level, and go to the households model, and we iterate, and we have a criteria to escape when there is no modification of the situation. So the top-down, bottom-up is they try to generalize the two approach, but it's not full integrated, it's separate. We have the transmission or the link from the CGE model to the households model or the household survey, and we have the reaction from the household level after absorbing the shock, and to look the situation on the top model, on the CGE model, and to do the loop until there is a convergence of situation. The graph you have here, it's from Colombo. It's from top-down, bottom-up approach. I hope you can read what we have here. Here we have the CGE model. We are looking after shock, what is the situation of change in price, wide and tourist ride, or order variables here. This is when we ran the model, we are here. In the situation, we are looking on what is the situation on the survey, in the micro simulation, in this situation, in that survey, in that units, statistical units. And in this situation, we are looking from the micro simulation situation, the variable of household, and it can be changed. But if we have all household change, their behavior is generally exactly what the government wants to do. There is an impact on the aggregate level, and the CGE model have to react. In the second situation, we have a new iteration, and after this reaction, we have a new vector of endogenous variable from the CGE model, the impact the household, and we have the loop of this. It's very interesting approach, but it's so advanced approach in the algorithm to program this situation is somewhat complex, but we can do that. This is the last approach we can present at this level. In the presentation, you have also many paper presented in this situation on using the macro simulation CG and micro simulation approach. You have here in Philippines, Norway. I think Zaki and Hindi, they have a situation for Egypt, and they will show you some other paper at this level. Okay. I think all there is more advanced or recent paper in some years, and it's more accurate for maybe for some of you if you are looking of presentation on this. There is some toolkits prepared and some manual, if you want, prepared by our colleague John Coburn and Luca Tiberti from the PEP network, preparing for if you want to see the top-down approach with the behavior. It's a very interesting toolkit. It is also in the PEP website. You can go just to put Coburn and Tiberti, and you can find the toolkit for the top-down microsimulation approach linked with the CG model. I'm looking for that time also, which is the approach which is the best approach. This is, I think, some of you have this question in mind. It depends of the research question you have. This is the first answer. It depends what question you have and what you want to look for. This is it, because we have many approaches. Which one we have to select if we have to do a research or we have to analyze a situation? It depends in your question you have. It depends on the data available. If we have no sufficient data, we cannot use one or the other approach. We have to use only one. It depends on the time frame you have. If you have 2 months, you cannot do a full integrated, or you cannot learn econometric approach if you want to do top-down with behaviors. Depending on human resource. If you are in a team or you are alone, you have to cover all these things. And some time it depends on your computer, but not. I hope no longer now, because in some situation the model will become big. I will give you an example in the second part of this session, because the model we are doing microsimulation is coming big and big, at least in the full integrated approach, and it can be a constraint to use some of these approaches. Okay. Do you have any question on that? I did it quickly, but we have to save time. Do you have any questions? Dorothy select for you many further reading and references if you want to go in the microsimulation approach. With the presentation, you will have access to all of the references. For some of you is working on this, it's interesting paper. It's yeah. I think this is the last slide. Okay. Do you have any question on that? No question? Pas de question? N'importe quelle question, c'est bon? OK. Je suppose qu'il n'y a pas de question. Just to show you some paper, this one. I will select this one. The first paper is mine. This Libération commerciale et pauvreté au Maroc, une analyse en équilibre général microsimulé. This is what we are looking here. It's to see what is the impact of liberalization in Morocco to access to, I don't know, l'OMC, or to reduce tariffs, etc. And we are looking on what is the consequences on poverty and others. It's with PEP, MIMAP in that time, and we are looking what is the situation on poverty. For example, here, for example, you are looking for the inequality. We can see on poverty and others, and we can do any distributional impact. Who is the loss? Who is the gaining? And we are looking for incidence curve, poor, non-poor. After the situation, we can do many distributional analysis. What we cannot do with the macro, the integrated model. Okay, the second paper here, it's with Dorothy and Luc Savard. We are looking for many situations from a CGE model in a full integrated model for the Moroccan situation, and we are looking for many policy, and we see what is the situation on the poverty and inequality, and we do to see on the some impact on household from this situation. We present the model, the contabilité sociale, the sum, and after that we look for situations. This is just to give you an example what we can do with this. It's feasible. You can do this, and this model is disaggregated. You look. We have many sectors here, and we can disaggregate at the macro level, at the macro situation for sectors, and we are projecting on the micro level. The last one is not in a CGE model, but it's the top model is in the top situation here. We are looking what is the impact of the COVID-19 pandemic on monitoring child poverty in Morocco. This is published in Microsimulation. Yes, in a Microsimulation review, and what we are analyzing here. What is the when there is a shock and there is the pandemic situation, what is the consequence on poverty? We want to see what is the impact on a child poverty. But to look the impact on a child poverty, we have to go through the household situation, and this is exactly what we do in this situation with a macro-sectorial level, but it's not a CGE model. And we do that through the Dorothy, she is looking for which where it's published in the
International Journal of Microsimulation.
International Journal of Microsimulation is published there. Now, is there any question on the framework? Why we are doing that? I hope you understand the object of why we have to do the microsimulation or to link CGE model with the survey using one or the other approach I presented here. Of course, if you want to use this approach, you have to go in depth in this approach. This just to tell you what we can do. After that, it's yours to look on. Okay, now. Okay, now, do you have any question here? When Shahir discussed yesterday on the model he presented yesterday, not extern, the model presented yesterday. In the first time we went, I have the preparation of this model to see in the small model presented by Shahir yesterday. The first thing I did is to construct a sum on that, and the object way I present that, I will not present the model after this, just to present you the object. This is the data, some data we can use to calibrate the model presented yesterday. And here we have the households. This is the column on the sum from the Shahir model presented yesterday. We have the sum here. And what is important is to look this column and this row. When we are reading a sum, here we have the income of the households. And this household, the household of this model, the representative household we have in this model, here we have the salaries. Here you have the return of capital. There we have the transfers from the government. This is the component of the income of the household, okay, in a representative household. In the column, if we read the column of this household, his household in the sample model it depends by buying the agricultural products and industrial products. And the total is expenditure. There is no saving in the model presented yesterday. Now, my question is, if we want to construct a micro simulation model from there, and to go over the representative household, what we have to do? The answer is we have to look to suppose this column concern many households, all households we have in a country, because we have only a survey. And from the survey, we want to look, how can we manage? So what you have to have in mind, the first step is to imagine this column, I don't know, disaggregated to many households. Each household have an extrapolation weight for all the population, and the same thing in the row. I will give you another example here. Look for this. This matrix is for the external model presented yesterday, and we have to construct a model from this. It's coming from the book presented by Shahir yesterday. What we have here, and please be here, because we are constructing, if you want to understand in the second part, and if you don't understand, just raise your hand and we will see. This is the model. This is the sum of the external model. If you see here, from the external model is from the book. What we are concerned here in this model, we have labor, capital, salaries, household from salaries, capitalistic household, firms, government, rest of the world, and activities. I will come back on it. And here we are looking for this column or this one or that one. What we have, the households, they receive, and here we have the same thing of households, household salaries, and capitalistic one. Here, the hypothesis of the model, we have here the mass salarial, the salaries here for households, and we have capital return for the capitalistic one, and we have here subsidies from the government to salaries households, and if there is other, we'll see. And here for the capitalistic one, in the current situation where in the expenditure side, here we have the taxes from the household to the government. Here we have expenditure on agricultural goods, industrial goods, or services for each group of households, because we have two categories of household. This is the complement of the sum, because the order, and we have here the same thing for household. And we have here a new thing, is the saving of household, of the saving of each group of households. Okay, this is the situation. We will see what is the model we can construct on this sum. Okay, is there any question on this sum? Because we have to construct on this. And I want to be sure you understand. Est-ce qu'il y a des questions sur cette matrice? No question? It's good. Okay, this is so just next step we have, and we have to understand, if you have a model in your situation, if you have a CGE model and you want to go and to construct a microsimulation model from the model you have, the first thing you have is to aggregate. The first step you have to do is to aggregate the two categories of households, here in rows, toutes les lignes, and in column. So we will have that one categories of households only. We don't need to have that two if you want to construct a microsimulation model. So the first thing you have to do is to construct. This is the sum, and here It's exactly the same we have before. Look what is in yellow here. We have only one household, representative household, and in the column we have one column of household. What we did here is only to aggregate, in this or this is the same one, to aggregate the capitalists and workers households in the column, and we aggregate in the row the same thing. And we have an aggregate household, a representative household. This is the sum, the aggregate sum, generally used in a CGE model, not a microsimulation model, in a CGE model. We have in the institutional agent here, we have households, firms, governments, and the rest of the world. And we are zooming, when we are doing microsimulation approach on household, we are zooming only on the two accounts in household, in a column, and in the row. Now, and I ask you, please, how many flow we have in the resource, in the income for the household? How many cells we have here? I am waiting for answer and to enter the interpretation. Combien de cellules nous avons de plein?
4.
Combien? 4. C'est-à-dire, we have here salaries, right?
Yes, salaries.
Capital?
Salaries, capital, rent. I still have a problem differentiating between why we add capital labor separately from the other side, but it's not a problem. And we have the transfers from governments.
Transfer from firms and
yes,
transfer
and
from government.
Voilà, yes.
Okay, bravo. C'est ça, exact. For some one order, please. What we have in the column, what flow we have in the column. Okay, go ahead. Someone. A volunteer. There is no volunteer.
Can I go on?
For,
yeah.
يلا علي d'abord et puis اسمع علي.
We have taxes we pay taxes for the government.
Yes.
And we have the expenditure, the agricultural expenditure, the industry expenditure, and the services. And the last one is saving.
Good. Ali is exact. No. So we have 1, 2 flow and 3 here. So we have 5 flow here, right? So in that row, we have 1, 2, 3, 4. In the column, we have 1, and here 3, so it's 4. And here we have saving, and the total is the income in the two situations. I am sure we will understand why I am asking this for. Okay, this is what we want to model. No. What I have to do if I have to construct a microsimulation model, I have the first is to understand what is the consequence of any policy modeled in the CGE model, in the macro CGE model, without microsimulation. I have to understand that because we have to do the microsimulation. If I can't understand the one with aggregated household, I cannot interpret the situation after that. So what we did, what we need now, I will show you, excuse me, okay, this is ça. Do you see my screen now?
Yes.
Okay. Sorry, Dorothy told me this is too small options. It's more, it's okay now? It's more clear, I hope. But okay, this is the model presented by Shahir yesterday. Here, what we have, Are you here? Huh? What we have is exactly the extra model presented by Shahir yesterday. And we have two households. There is no microsimulation. We have two categories of household, two group of households. And we have the model. It's exactly what we analyzed yesterday. Here, this is exactly the model. And here, the calibration of the model. Here we have variables. Here we have equations of the model. The model is what Shahir presented yesterday. Particularly, he speaks about Armington, export, CET, and so on, equilibrium condition. And here we can introduce our simulation here. We can see which simulation we have to introduce. Just to see the model, just for an idea, we are using the GAMS IDE, not GAMS Studio, because we have a problem with our license. Because we have a license for GAMS IDE, because we are using a very large model, and our GAMS Studio, we have not the license. Now, I execute the model in this situation. There is no microsimulation approach. This is only scriptural. Do you see the results? Do you see the results, please? Okay. Yeah. This is, you see here, we have the solution, and we have all the results we need to see. The model is just to be sure, is a square. It's with single equation, single variable, and all things is good. And we are using the solver is the SPAT, is exactly what we used yesterday. There's no new thing. Well, yes, we can see Dorothy is asking me to see what is the situation for the Leon value here. I will do it here. So, okay. You can see here the variable to be sure that the model is correctly calibrated, and we have the value is 0, approximately is a 0 value. So our model is good. Now we can, of course, we can do any simulation, and I will ask you to give me one simulation you want to do. Ali, here we have to introduce our simulation. Here, we are looking for where we have generally a fixed value. What shock we will introduce here? It can be a complex one. Yes, I'm waiting for propositions. From there.
I don't know.
You don't know?
We can change, for example, the prices.
Prices, okay. I will do exchanges of prices. Okay, one price increase with 5%.
5%, yes.
International here, and the export increase by 10%. And I don't know which other thing, the labor supply, what increase by 3% for migration. And I don't know what order. It's good. It's sufficient. We can do any simulation we want to do here. We can, and we have to. This is what we call simulation. Now we can see what is the consequence on that. If we increase the labor force, the salary can change, etc. This is what Shahir explained yesterday. And we execute the model, they execute the resolution and the solution found, and we can go and see exactly the result. This morning, I add just one small thing. Where is it here? We added, I don't know, Shahir, we have speak about Dorothy. Dorothy, explain you what we can add results here. We have a GDX file. You see here? GDX. Do you see it, Shahir? It's clear?
Yes.
GDX.
Yes.
Why we add here that? Because it gives us a possibility to go from the results from GAMS framework to the results. Just to give you what results we have. Just to give you an example, GDX. Just to give you what it sums, it's CGI point base, CGI here. Do you see the results here? Do you see the situation here? This is all results we have, parameter and variable in alphabetic order. So we can see the situation of all import, export. Look for the domestic value of the variable. This is the level of the domestic offer. Yesterday, Shahir gives you the framework, or we are looking from the COT and CUS. Here we have that. We can see on, I don't know, in imports, because we have a shock on imports. We can see what's the situation. This is the import, and we can compare with the level before in the. This is the situation in the reference situation, and we have here. This is a parameter, and this is the variable after that, and we can export to Excel and order, just to give you the situation when we are using the GDX approach. Now, is there any question in this level? I will move to the second model. Okay, not yet on the microsimulation one, but here, what I did, I present you a situation where we have one household. This is the model constructed by aggregating the salary households and capitalistic one. Generally, what we have when we construct only on one household situation. The model is globally the same, but for the data now, we have only one household. Before, we have here two categories of households. Now we have only one. And we can, there is no shock. Just to give you an example, here, this is exactly the same. And here we have there is no simulation, but we can add the simulation. And here I execute the aggregated model. Like before, I hope we have the solution of the model. It's small than that previous one. Do you have a question? The number of equation and the number of variable is reduced, because before we had two households, two categories of households. Here we have one category of households, and we have all the solution we want to see and variables, etc. We can see for the Leon here also. Maybe. Here for the Leon variable. Oh, descendre. Ici, we have the value of all the value of the problem we have. Okay. Now, the next step is exactly what the object of this session. When we want to construct, this is the Leon, just to be sure. Our here, Shahir, this is the Leon and it's 0. Okay, we can do our simulation now with one household, and we can introduce exactly the same simulation like before. I don't know here 1.5, 1.5. This I will do the simulation, something like that, and we have the result for the house when we have one. Sorry,
you forgot the multiplication.
Bravo, merci. Tu me suis. C'est qui a parlé? C'est Asma. Merci, Asma. J'ai forgot. It's a good exercise to see how to correct. We have the zero rules to read. So, and now it's corrected and we have the situation. Okay, this is clear. Now, next step is to construct our microsimulation model. But to go there, we have to go and to see for data from a survey. We need data in the down situation. We need the data from households. From where? Où est-ce qu'on peut avoir ces données? From which is the source of the data for households? Yes.
Surveys.
Household surveys.
Household surveys, exactly. So for this exercise, with Dorothy, we prepare for you I give you the example here. We prepared for you data, and we will send you sorry. Ça va, vous voyez mieux, c'est bon? C'est bon? Okay, now, if you are looking for this, what we have here, just to, sorry, just to because I am using two screens. Okay. So I hope you know what is data. So here we have a survey, and we have here data. We have 4,700 households. This is data we have, and we can see all data we have here. Sorry. This is the data of what we have for each household. Okay, we have here, I don't know if you can see more. Group access, what was it? Yes, review. Where is it? Okay, you can see clearly here now?
Yes.
Here we have the household, the identification. I will come back to this poids, and we have here the flow. This is why I asked you before what we need. We are looking for the sum, the flow we have for salaries, capital, transfer from firm, transfer from government. This is the total of the revenue. We have the import, it's this the Ali answers, and we have the expenditure for each goods. Here we have the sizing, ici on a la taille du ménage, the household size, etc. This is the data from the survey. Okay, just one remark. Look here, for some households we have a negative value. Okay, we have to look the data before going further. For some households, it's clear we have a negative saving. This will have a consequence when we have to model this situation in a micro level. Okay, this is the situation, the data we have. Now, in the situation, in the reference situation, we can do many things just to you have the data you see here. I hope you can see what we are doing here. Here we look for the expenditure per capita in each household, and we calculate the poverty line, and we can calculate poverty index, Gini index, the composition of poverty. Just to give you an example, why we want to do microsimulation, why the CG, the global or the macro model cannot answer some of our questions. Just to give you the situation in the base year, we have here in with this data, we have here the poverty, the incidence. The incidence of poverty, the FGT when alpha equals 0, the poverty when alpha equals 1, it's the gap, poverty gap, and severity of poverty. And we can, in that situation, the reference situation, we can calculate the Gini index, tail index, etc. For this situation, here we have the Gini index. Okay. Okay, this is what we have in that situation, in the reference situation. Okay, so when we have this data, we will, after that, export this data. If you see here, we are preparing the data to go to GAMS and to model in a microsimulation approach. So now we have two pieces. We have the CGE model in aggregated level with one categories of households, and the other pieces here we have the survey when all data household by household, and we have, just to recall, this is what we have, the number of households we have in our survey. So in the full integrated approach, we have to modelize all the behavior of all these households inside the CGE model. The column and the row of in the sum before we have to, I don't know, no, that was disaggregate. We have to disaggregate the household account in row and in the column, and to imagine we have these lines or row and columns in a sum. This is the first thing to do, but it's not easy because we have to be sure when we use this household survey to be consistent, to be coherent with the sum we have. Just to give you, when we are looking for expenditure, we have to look, is the expenditure from the household when using the extrapolation, where we are using the weight, gives us all this value. When we extrapolate the revenue from salaries and capital or transfers from firms or from government, we have that. This is not trivial. This is the biggest problem when we are constructing a microsimulation model or a CG microsimulation model, because we have to look if there is a coherence between the microdata and the sum we have, from the households level to the sum we have. It's clear that is the problem clear? Is there any? Yeah, Ali.
Yes, it's okay.
It's okay. Good.
Yeah.
Now, to assure that in the first part in the presentation, I told you that we need to use what we call the cross-entropy approach. This is exactly what we have to do to be sure to start our microsimulation construction using the cross-entropy approach, to be sure when we extrapolating the data from the survey, we have exactly the value in the sum. And after that, we can go to construct this. Just to stop me. Yes, now, what is the cross-entropy approach? The cross-entropy approach is produced by a group of researchers, maybe 1994. It's a paper, it's Golan and all, presented in Restat. It's a very interesting paper. I recommend you to read it because it's a very powerful approach to assure there is a link between microdata and macrodata, sectorial data and others. And we can program it as you see here. But before I go here, I will stop sharing my screen and I let Dorothy to share her screen, okay? Arrêtez le partage in my side and Dorothy will present, I will present. I have to present, okay. Do you have do you see that Dorothy screen? Do you see? Yes.
Yes.
Okay. It's a mathematical, the cross entropy approach is objective approach and it's a mathematical approach. Here we are using one of our paper, Dorothy and me, but just to give you an idea what we want to do. I present you the first thing, the flow we have when we are looking, le modèle avec les flux qui est en annexe. Ça. Yes, something like that. We have here, we are looking for value. Suppose what you have in to minimize here, we have a criteria. This is a cross entropy criteria. What are looking? We are looking for the flow of U and W is the new extrapolation. What's the story? If you want to be sure there is a consistency, a coherency between the microdata and the sum, we have three possibilities, three variables to adjust. The first one is the extrapolation coefficient, the ponderation coefficient, because we can change that to be sure we can assure the equality between the extrapolation flow and the value in the sum. Second possibility is to change the value of the flow, like here, the value of the flow we have, but now be sure we have many flows, 4 in the row and order, at least 4 order in the column. Or we have to change the weight and to change the flow. So, and we have to minimize the criteria. The cross entropy approach is to minimize the difference between the two. Look at the report, look at inside the logarithm you have here. In the denominator, you have the observed one, what is inconsistent, and at the numerator is what we are looking for. And we need that when we aggregating the weight, we find the value of the population level, and when we extrapolate each flow for the level of all the economy, we have the national accounting value, or what's the value in the sum. This is the philosophy. I cannot go through that, but what you have to take in mind, the cross entropy approach is an objective approach that can help us objectively to find exactly the same results to conciliate the data from the household level to the macro level, and with all the constraints we have. But generally, the value here is too big because it's in million lira or million dirhams or million dinar, and the value of W is big. The approach proposed by Golan and all is to go through the transformation is the mathematical problem in a coefficient, but with an equivalent program. Dorothy will show you now the equivalent of this model, but in a transformed model, because it is more easy to deal with a value of the coefficient technique, of technical coefficient. This is what we have here. It's exactly the same model, but right, it's put here in the technical coefficient, because all the E coefficients are between 0 and 1, and it is more easy for at a numerical level to solve a model like this. So what we have to program now, what is the story why we introduce this cross-entropy approach here. To remind you that we introduced this approach to be sure the data we are using from the survey, we have to correct something. We have not to touch the sum, because the sum is fixed in a CGE model level. We have not to touch that, but we change in the survey, particularly when we have a sum for 1 year, or particular year. I don't know which year you have in each country, and we have the orders. You see? The pause, yes. We will stop here, and after 15 minutes, 15 minutes, we will restart, and we go from the cross-entropy approach in GAMS. If you have questions, or prepare your questions after the pause, after the stop break, or if you have any questions. OK? 15 minutes, Shahir, 15 minutes?
Yes. Oui, tout à fait. Merci, Tohabi.
Yallah. Préparez vos questions pour n'importe quelle question, que ce soit au niveau GAMS ou au niveau cross-entropie, puis on revient sur le modèle. OK? À tout de suite.
À tout de suite.
Now, we have to start our model in a micro-simulation approach. And what we have to change from the CG standard, what steps we have. I will go slowly in this part. And if you have any question in any point, please you stop me. So the model we have is to construct all the flow to be consistent with the survey. We use exactly the same model we see before, but in a microsimulation situation. First thing, Dorothy, your hand is raised. Tu as levé la main.
Non.
Ben, je le vois ici. Okay. Yes, it's good. Do you have any question? Is there any question? Good. Now, the first thing we have to answer in when we are doing a microsimulation approach in a top-down, here we have the size of the survey we are using. H is the index of the household, the identifier of the household, and here we have all households we have. Here, there is no new thing. This is what we had in our extern, in the aggregated situation. No, there's no new thing. Here, we add, just to verify some things. Here, we have to be sure he knows that the number, the cardinal of the survey we have, the size of our sample used in the survey. And after that, and here is a new things. Just I will select some and to interpret that, just to stop here. And I hope you are looking for my screen. Okay. What we have? We have from the enquête, from the survey, we have the consumption of the households good by goods for each good that we have here, where we look at the situation in a strata. We have the consumption of the household in agricultural products, goods, industrial goods, and services. So here, this is the equivalent on a GAMS situation. And here, okay. Can you see? So it's better? Okay. And here we have the total consumption of the households by product is the total of consumption of all the product. This is the value we have in the sum. Okay, this is the value we have in the sum. Just before the break, we introduced the technical coefficient. here we define we will see what's the definition, the value here, but here we have the definition of coefficient we have to use in our model. It's exactly the same thing for any flow we have in the sum. So the story is, each flow we have in the sum, we have the equivalent, but for each household, and we have to calculate the coefficient for each household. Now, the flow we have in the sum are for salaries, for capital, for transfers, etc. So we have, for each flow, we have to introduce, to define what we need. At in the end here, we have to do the same thing, but in this situation, it's not a flow. It's the coefficient when we have to extrapolate to go from the survey to the population. In Astata, is that if we add, I hope you know that, if we add all the value of the extrapolation weight of all households, we have to the population level of what we have. This is what we have here. So this is for the coefficient, extrapolation coefficient of the survey, and we have to be sure from the survey and the demographic data is correct. On doit respecter le total démographique qui n'est pas celui de l'enquête. Lorsque j'extrapole l'enquête, je trouve des valeurs différentes. And we have to respect that. This is other parameter we have, and we have to have it in that. Now, is there any question at this first block?
I just want to ask a question.
Wait. Yes.
On the coefficients that we use in the beginning, from the entropy. So the ACO, the ASALO,
yes,
the ACAPO, and so on.
Yes.
So all these coefficients, would you please explain how can we obtain them once again, this consistency between the entropy and what we introduce in GAMS?
Yes. What we introduce in GAMS, we will come at the end. This is what we are. Ça, c'est ce qu'on observe.
Okay.
After that, in the solution, after that, we have to deduce the value for each household. When we extrapolate that, we will find the value on the sum.
Okay. Yeah.
Because this is what this a parameter. All this is read from the data we have. This is cool. Where we start with we have to calculate it. Just in a minute, I will show you the calcul. Dans quelques minutes, je vais vous montrer comment on calcule les A. Ce que l'on a observé dans les enquêtes, ce sont les valeurs que l'on a là. Ça, par exemple, c'est observé dans l'enquête. Le revenu salarial du ménage, le revenu du capital du ménage, ça c'est quelque chose qu'on a approximé dans l'enquête. D'accord? Oui. Et lorsqu'on va l'extrapoler, qu'est-ce qu'on doit trouver? On doit trouver ce qu'on a dans la somme, ce qu'on a dans la matrice. Mais une fois extrapolé, évidemment, si vous faites la somme juste dans l'échantillon, vous allez avoir juste 4 000 ménages. On n'a pas 4 millions de ménages. Vous voyez ce que je veux dire?
Tout à fait, oui, oui.
Donc, c'est en extrapolant qu'on doit trouver ce qu'il y a dans la matrice. Et donc, ça, on doit faire attention. Ali.
Thank you, Mr. Thiami. Just one question.
Yes.
If we believe that the information of the survey is the good one,
yes,
why would be to proceed
to the sum.
Before, yes, before so we correct the sum because it's administrative data.
Yeah. Yes.
Yes, we correct the sum because we believe that is the administrative data using the survey data. Then we proceed directly and we run our model.
Yes, Ali, if you are confident with the data from the survey, it's just an hypothesis. You have to change the sum. So in this situation, we have to change from the extrapolation from the survey, and we have the value what we have to put in the cells in the matrice. C'est-à-dire que dans ce cas, j'extrapole mon enquête, je prends les valeurs que j'ai dans l'enquête, je le mets dans la matrice qui va être déséquilibrée et je dois équilibrer la matrice. Et là encore, je dois utiliser la cross-entropie sous un autre schéma. Tu as raison, mais je n'ai pas voulu parler de ça puisque ça va vous perturber. Mais c'est tout à fait possible. Just to translate, Ali asked if we have the possibility to be confident on the survey, and we have to change in this situation the sum, the value of household in the sum. But if we change the value on the sum for households, we have to change all the other account in the sum. We have to choose. It depends on the situation you have. But generally, what we do is to change the value in the sum because il y a au moins deux types d'erreurs. There is the sampling errors and the observation errors. We cannot be confident generally on the survey. We are more confident on the contability and order in, I don't know, in trade or the government observation or order. Ali, before Gracia Rahi, there is another question before you, Ali.
Okay, thank you.
Thank you, Doctor. If I may, just to add to Ali and to make sure that I understand well. So in this exercise, you are exploring one option. The first option is to calculate the weight.
Or the flow. Weight or the flow. I am not really. Yes, we have to calculate. We have, in this situation, true. Ali asked for the first question. Have we to be confident on the sum on the survey? If we are not confident on the survey, what we have to change in the survey? We have to change in the survey three possibilities: to change the weight, to change the flow, or to change the flow and weight. I hope it's clear, Gracia?
Yes, it's much clearer. And I have other question.
Yes.
So, like at each block, so first we are treating the consumption, then the salaries, etc. So at each step, we are only considering like consumption to calculate the coefficient. So at each time, we like in order to, for example, to compute ACO, we will only work on the values in the consumption variables, or we will take into account the
we have
whole,
to do that simultaneously, Gracia. We have to do that
okay.
simultaneously. I am coming in 10 minutes or 15 minutes. Your question, we found the answer. Okay.
And last question, I did not really understand the last three ones, like the last the W. Yes,
here.
I did not.
Here, because generally, if you are using a survey, you can see we are in each country, Gracia. Where are you? Where are you, Gracia?
Right now, Lebanon.
Yes. Lebanon. If you are in Lebanon and you have a survey from Lebanon, you are looking the extrapolation where you look for the sum of extrapolation weight, because your survey is only, I don't know, 11,000 households in your survey. When you extrapolate, you must find the number of households in Lebanon. This is the story. But if you did that and you compare with the demographic information of the population by households in Lebanon, there is a difference. And what we have to, we change the coefficient. We change the coefficient of extrapolation because we are sure we cannot reach all the household. There are difference between what we have in the plan sondage, when we construct the survey plan for the survey, and there is many differences. And we can change also the coefficient. So we can change the flow of value in currency, local currency, or we can change the extrapolation coefficient to be consistent with the demographic projection of the data. I don't know, it's clear.
Yes, much clearer. Thanks.
It's clear. Ali,
yes.
Tu avais toujours une question, Ali.
Yes,
Ali.
yeah, just
Oui.
because the approach that you are proposing here to correct to consider the survey in the model is just to correct the difference between this information of the sum and the information coming from the survey. So
Yes.
it's like an error term that we
Yeah.
try to minimizing.
It's a conciliation. Ce qu'on est en train de faire, Ali, c'est conciliation entre des données macro et des données micro pour que l'on puisse commencer la modélisation. C'est tout. Maintenant, il faut que la conciliation soit faite sur des bases rigoureuses, objectives. C'est pas que Ali va changer les salaires, moi je vais changer le capital, l'autre va changer autre. Non, non, il y a un framework clair et mathématique solide. This is what we are trying to do.
Thank you, Mr. Thiam.
Est-ce que la logique est claire? La philosophie de la chose est claire? C'est bon?
Oui, oui.
Good. Now, is there any other question? I'm happy to answer your question if there is any questions. Okay, now.
I have one
Yes.
small observation about the first line. About consumption.
Yes.
When you are like CO, why don't we have an index?
We can put it
because it's par produit, yeah.
Et c'est facultatif. Vous avez raison. Je peux mettre ici C entre parenthèses H, virgule I. C'est ça ce que tu veux me dire?
Oui, c'est tout à fait ça.
Oui, je peux ici, dans ce cas-là, c'est facultatif. On va le voir dans quelques minutes. Tu as raison, mais c'est facultatif. Ça va? Est-ce que ça répond à la question?
Parfaitement, merci.
Très bien, c'est facultatif. Et on va le voir dans quelques minutes. Now, on continue. Ça, c'est la définition des paramètres, the definition of parameter. Now, here, we have to import the data from Stata. We have to use, if you look here, in Stata, we have to export. Here, we have to export after the job, what we have to do in Stata, in our survey, we have to export data to GAMS. It's exactly what we have we do here. And here, I give you two methods to import data in GAMS. When we are using GAMS, we can import data $lib include XL import. I define here a matrix, and here I import exactly the file I defined before in Stata, because I export from, I save something here in a Stata, I save it in Stata in XLS form, in the sheet enquête, and I have the position of each thing. So in Stata, I produce the output in Stata, and here I am using exactly the same thing. Look here, I have the number of households plus 1, because the first row is the name of variable in Excel file, because I have here the number of households is exactly the same number of households plus 1. And here, what GAMS have to do, it's only to try to retry the data from Excel. If you want, we can verify that. I have to add here just to show you exactly what I am doing. I will do it on text. Okay, sorry. Wait. On text. Alors, in white. Je ne sais pas si je peux le trouver en bas. Just to give you an possibility of text. Je ne sais pas si je peux ici. Just to neutralize the rest of the model and to show you what we are doing exactly. C'est ça ce que j'ai ajouté. Ça, je peux faire comme ça. Comme ça. Il y a un autre. I think Dorothy told you last time, start with the GAMS, we can put on text off text to neutralize the part we have here. Where is that? Non, avant ça. Autre chose, just to see. Okay. Now I will run this part of the model and I show you the situation. Okay. Is now we are only reading the data. And if I go here in Stata, I saw this is the number of household in GAMS, sorry. This is the number of household I have. And if I add now to read the data, I will do it in a second. Look that. Here, I read the data from Excel and I ask GAMS to look what I have now, what he has in the situation. I'm sorry, but we are applying to understand exactly what we are doing. Here we have the data. So what we have here we have all the data, the transfer from the firm, the transfer from the government, all the variable we have in the survey are now read by in GAMS for all our variables and all that. So now we are ready to go ahead because we have that situation. We can do that in this form, and we can do that in another form here. If you want to use a CSV form, it's exactly the same thing. Just to give you the example. Now, if there's any problems, stop me, please. So now we can read the data, so no problem. Here, because we read the data in a free form, because we put here a star, we have to affect here in this part, we just affect data to our parameter, because we read the data from the matrix from here, and here we give for each scalar the value of that, and we can see the result we have here, just to show you this step what it means. I ran it another time just to show you exactly what we are doing here. It's open, GDX, where is it? Ici. On text, ici. And off text, ici. Okay. Okay, now we go to see. Now we have the data, but we have also the vectors. All the data we had in the survey are here now. All, you see? So, is another step. And I recommend you to put the display here to be sure you are reading the right things here, okay? Now, on continue. Here, what we have here, just to show you. Are you with me, please? Okay. If you are here, we can show exactly the data we have on the sum. Look, this is the value of the salaries here. This is the value of capital. This is firm value, government transfers, and so on. Now, here is the consumption. This is the salary. This is the capital. This is the value we have to respect in a demographic level, the number of households, and the demographic level in the population level, all the population. And here we have the data from the sum. Ali, this is exactly what we have to respect. This is the total value we have to respect, because in the macro level, this is the data we have. And when we have to run our calibration, we must be sure we have all these respected. So now, I continue. This is, if we see, Shahir. Now, this is the answer for your question, Shahir. Here we have to calculate, because for coefficient, we don't read them. We have to calculate them. Les coefficients observés, on va les calculer. How to calculate that? It's exactly like in input-output table. We take the value and I think Asma, or I think there is the value Asma. We can use it, no problem, or we not declare the indices before, but no problem. Donc, ici, what we have to calculate, for each household, the value that we have in the survey, read it before and affected before, on the total. This is la valeur initiale. C'est ce qu'on a appelé tout à l'heure dans le dénominateur observed in the cross-entropy approach. This is like when we are calculating the technical coefficient in an input-output analysis. This is the value for each household observed. This is the coefficient we want. This is the observed salary from the survey, and this is the total we have to respect. So we calculate.
This is the total of the social accounting matrix.
Yes, exactly. The total of social accounting matrix. You're right. Check. Ça va?
Yes.
C'est exactly that. Donc, ici, les dénominateurs sont exactement ceux qu'on va devoir respecter. Maintenant, ces coefficients ne sont pas consistants because we know it's different from that, and we have to change that. Now, this is the calibration level, if you want, the calibration level for the technical coefficient. Just to be sure, there is no mistake, there's no error in my program at this level. And we have all the coefficient. Here we have the coefficient calculated here. You see, it's a small value because we have, for each household, we have the value we have. Okay, now, is there any question at this level? Okay, je supprime ça. Now, we start the real cross-entropy model, because before this is a calibration is only between value, read value or calculated one. Now we have to define variables. So if you see, just I take one, look this one, it's with O. I think Dorothy, when she introduced the GAMS, she speaks that when we observe the value in the reference year or reference data, we put O or n'ajoute O. Here we did something like that. Here we have the same thing. I define variables. Here it was a parameter. Here it will be the value I am looking for. So here we define the variables. Before I told you that the saving can be negative, but the other variables are positive. This is economic reality, the economic data. So here I post positive variables because all those must be positive, and this one can be negative. I put it outside. It's a variable. I finish by this point virgule, and after that I did exactly the same thing, but in this situation with variable, with not positive variable, because the saving can be negative. Is there any question? Good. Now, the criteria, the cross-entropy criteria we have to minimize, we have three possibilities. And I think with Asma, we have three possibilities. We have to change only the flow, only the weight, or to change weight and flow. The model can be big, but it gives me more space, more degree of freedom to calibrate my situation. Just to give you an approach, on est en train de faire un lissage des erreurs pour ne pas faire supporter à certaines variables toutes les erreurs. Plus vous avez de variables, moins vous allez déformer la réalité. Puisqu'on ne va pas faire supporter à une seule variable le poids. Donc, plus il est large, mieux c'est. Donc, here we have three possibilities. Change the flow, change the weight only, or change together, weight and flow. And now, we construct our model. I think you have to read the paper of the Golan, George, and all. Here we have the value we have to minimize, and we have all constraints we have to satisfy. I will become one by one after. This is the constraint. There is some mathematical techniques behind, but we have no time to go. But this is what we have to look for. The first model is only if we change the flow. If you look of my equations here, I added F to signify flow to we are in the flow model. Here I add W here to tell that we are considering the weight as the value we have to change. And here I add G here to signify that I have to change. I can change the flow and the weight. Okay. Now I put my own text here just for one moment, just to be sure I have no error before, to be sure I am correct. I ran the part of the GAPS file. Now there is no error. Now here I will go slowly, and Dorothy, can you read my screen, please, là-bas? Just to be sure we understand. Est-ce que vous pouvez lire, Shahir, ici? Shahir, ça va?
Oui, oui, oui.
Okay.
Là, on a le code GAMS.
OK, alors dans le code GAMS, in this code, I let you look just to see exactly what we are doing. Look at here. We have the variable object. It's a variable. This is the equation. Point ici, we add dot. It's a syntax. It's a GAMS syntax. And look here. I select, just to be more clear, I select salaire here, just to go what. On va avoir, c'est la somme sur H, it's sum on H, because on households, on the total we have here, and this is the variable. This is known. It's the value we know. This is the coefficient we are looking for. Multiplié par, it's exactly what Dorothée showed you before, because we have A log de A sur A étoile qui est connu. But we must be sure this value is positive and not equal to 0. To be sure of that, we add a condition here. The condition here is to tell to GAMS, don't go on if it's 0, because some household, there is no capital revenue in my survey. In my survey, some household, there is no capital because they are only salaries, or inverse, or some household, there is no government transfers. Ils n'ont pas de transfert. Et donc, si je ne le fais pas, il va avoir une erreur, puisqu'il va considérer une valeur nulle. Et donc, I have to exclude in my criteria the value where, because I am using the logarithm, I have to exclude the negative or null variable here. I can. So this is why we put. And here we can, the criteria is one question before. I told you that the answer will come in 20 minutes. We are doing that simultaneously. I have to solve the problem simultaneously for consumption, for salaries, for all the flow I have, except one, except ici, I put it, expression, except saving. Why? Except saving, because saving can be negative. If I change that, I have to change the criteria, and I can use a key to square, un critère qui carré ou un critère quadratique autre qui lui accepte des valeurs négatives. C'est pas ce que je veux. Je voudrais vous faire passer la cross-entropie. Donc, ici, j'utilise le critère entropie qui repose sur un lissage des erreurs. Voici le cœur de l'entropie, c'est ça. Le critère que l'on a. Gracia, yes. Question, yes.
Yes, I have a question on the non-zero condition.
Yes.
So, for example, let's say in the first one we have an observation with a 0.
Yes.
Does it drop this 0 observation for
no,
all?
it's
Only
zero.
for
It
the
cannot
first one?
influence my criteria. It's because 0, I have not to consider it. It must be 0. If it's 0, is like you have a household, there is no government transfer because it's a rich household. What I have to do in my simulation, I don't want that this household earn from a transfer from the government. So for this, I have to put it as exogenous, and in my criteria, I cannot put it here because if I put with a zero value here, the logarithm cannot be calculated. The ratio cannot be calculated, and the logarithm cannot be calculated. If I want to calculate with some negative value on zero value, I have to change the criteria. But if you change the criteria, you have to use an analytical criteria. This is not good because in the paper in Georgia, there is a book entitled Econometric Entropy. There is a book on the entropy. So you have it's George and Miller.
I give the reference.
I think Dorothy in the chat send you the references. Thank you, Dorothy. You have in the chat, Dorothy send you now the paper or the address. Okay, maximum entropy econometrics. This is the best criteria we have to use when we are looking for the conciliation on macro data with micro data. Okay, I don't know. It's Gracia? You have answer, Gracia?
Not 100% sure, but maybe if like we continue, maybe it will.
No, you can ask. If it's not clear, ask. Yes.
It's just that, like technically speaking, I don't like what I want to make sure to understand is that, for example, if I understand why we need to take out an observation with zero because the logarithm won't work, but so this observation in this equation will be removed.
No,
just to be able to compute the log.
The observation still in my analysis, but I don't take it here. But in the analysis, there is no loss of information, no loss in the statistical units. All my household still there.
Okay.
But if he has zero in input, I am looking for, he must have zero in the output. I cannot produce the value for a household where we have no observation and give him an observation. It's not plausible in economic level. Okay? Okay. So this is the criteria. Only the negative when for the saving. Now, this is the very difficult part. Please be here. Now, what we want to do, there is some mathematical approach here, but we have to extrapolate. When we extrapolate, you can put, if you want, this outside, but we are looking here to tell him, Ali, is exactly your answer for your question. When we extrapolate each consumption, we must find the value in the sum for each flow. This constraint is mathematically equivalent to, when we extrapolate in after, this is the solution, the value of the solution we are looking for. When we extrapolate, we must find exactly the value we have here, and we will verify that. On doit trouver exactement les valeurs que l'on a. And these conditions are simultaneously answered. This is one. The last point, and it's a very difficult one, is for each household in the matrix I showed you before, we have a point. I asked you to look. Here we have 4,700 column and 4,700 row. And we have to be sure the total for in each row equal the total for each column, because this is the definition of a sum. And virtually here we have a sum. And the condition is like this. The value of the household, each household, on salaries, capital, firm transfer, government, must be equal to import, the part of import of the household, the part of saving of the household, and his consumption. If you look at that, this is the budget contract for each household. And it must be satisfied for the endogenous value. We must respect that. We must respect that to have exactly what we need to construct a Microsimulation. This is why it is difficult to satisfy a short condition. It's right for each household what we have in the survey. Okay, do you understand this point? Shahir, I am looking if there is a question. Alors, je vais reprendre, to be more clear, at least for the front one. Ici, nous avons le critère cross-entropie que nous voulons optimiser. Il est de la forme somme, ou double somme, comme vous voulez, de la somme des flux. Logarithme, la somme, le flux pour chaque ménage, et le flux pour chaque ménage que nous cherchons, divisé par le flux observé qui est non consistant, nous voulons minimiser cet écart, sous contrainte que la solution doit respecter les conditions comptables de la matrice de comptabilité sociale au niveau de chaque cellule, lorsque c'est extrapolé, et au niveau de chaque ménage pour assurer l'équilibre ressources-emploi pour chaque ménage. C'est ça ce qu'on est en train de faire. Je vais sauter pour aller vous montrer, rappelez-vous de ça, je vais revenir après, si on veut changer les poids d'extrapolation, je fais comme ça. Regardons le reste, juste pour vous donner un peu l'exemple. Ici, je remets ça, excusez-moi, puisque je le fais en direct avec vous. Ça, c'est on texte, c'est off texte. Ici, regardons ce premier modèle. Look for the first model here. In GAMS, yesterday, in the end of the session yesterday, Shahir tell you about solvers. When we have to solve a model, when we have to solve a square model, we can use CMP, CNS, etc. Here, we have to optimize. We have not to solve. We have to minimize the criteria. So we have to use all the equation I have in my model here. If you look for the 9 of equations, sorry, here with F, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have all the equations, and it's exactly what we have here. Here I define my model with for flow, here for weight, and here for all. And we give the initialization here, the value where we start our resolution. Here I give the low value, the lower value, when we put in GAMS, point L is for level, this is for lower, is the variable, and here is a lower value. Here we put for the upper value to help the solver to go to right to the solutions. And here, if the value is null, to put 0, and here to solve. What we are solving? We are solving this. Look at. We have to minimize my model is here, minimize the objective, the value of the function I have using a nonlinear programming. This is your question, Shahir, yesterday. We can use CONOPT, we can use Minos, we can use IPTOP. This is solvers if you have the lessons, because the model is big, very big, okay? And after that, we can resolve. Just to show you exactly what we do here, I put here just ça. Okay, to look, maybe I put many stars before. Okay. Okay. I tried. He is reading. Now he's starting a resolution of a very big model. We are looking for at least 9 valeurs pour 4700 quelques ménages. It takes time, some time, and he found the optimal solution. Il trouve la solution qui nous intéresse. What it means, he found the solution. We have the solution for the new technical coefficient and for the new value. And the new value we have is the value we need to go in that simulation model. We have all the value we need for each household. It's different than the value we have in the input survey. It's changing, but we have to change only marginally for each variable because we have many variables. Just to give you a statistic of this model, if you look here, statistic of the model, look at the number single variables we have. Regardez le nombre de variables qu'on a. Why? Because we have 4700 ménages et on a plusieurs flux. Donc là, we have the value of what we need to export to our model to solve the real model. Because here we are now we.
And just a question here. Here the
Yes.
the single equations that we have, the 4000 represents the number of households, right?
Yes, the single equation is 1 by households. Yes.
Yes.
And here we have the number of variables because for each household we have many flows.
So the labor, the wage, the capital rent, the transfers,
wage,
and so on.
transfer for government, and the saving, etc.
Yes.
Yes.
Thank you.
Okay. So the value we have, the new variables are there. If I give you, just to give you an example, this is when we extrapolate, this is the value for household 1, for household 2, extrapolated for the population level. Okay? Donc, because Dorothée reminded me that we have 30 minutes left, I prefer to go for the model and come back in this situation if we need. Now, we can solve the model, as I told you before, for the flow, for the, here there is a problem, but we can do it for the weight, and we can do it for the global one where we change simultaneously flow and extrapolations weight of this situation. And here we recalculate to come back to have the value because we have the definition of the technical coefficient by the situation of what we have to respect, the sum value, and here with the extrapolation coefficient, and to retrouver the value of the sum we have. Now we are ready to go. Just one other remark, but please. Now, because the model is big in microsimulation, this is the situation. This here is just one remark. I don't know if you, Dorothée, I use you as témoin. Do you have to see here something?
Very small.
Can you see? It's very small here. I don't know. Can I?
Here, maybe.
Comment? Just to. Can you see something here? Shahir?
Yes, Calib Microsim.
Yes, with S, with some S here.
Yes.
The small S here is to tell to GAMS save. He has to solve the model because it's big, and they have to save the output because I have to use it as input in the CGE model. I will go now to the model. This is now he calculated all what we need as input data for the second step, the big steps we have. So now I will go here and I will present you the model. And after that, if we need, we come back. Look here. This is our model. Is the very difficult part when we are doing microsimulation, full integrated microsimulation, is when what we construct before. Now we go to the model, the real model, and I will show you what we have to change. Look at here. Now I am in another file. Look at this, what we put here. Now we put exactly the same thing, but with a small letter here. Before it was a Calculating, and now it's R. R, c'est pour retrieve. Donc in the first one, it's save, retrieve. Here, I asked him to use the solution from that fourth part. And here we have the model. There is no difference at this level. When we defined before, just to show you this, before we defined that set R. So when I ask him to retry, he knows the set. Now I have not to redefine it. All what is here is defined before. Now this is the model, exactly what Shahir presented to you yesterday. Exactly the same thing. It's coming from the aggregate model, but now Ash is for all the household we have, and we are sure it's consistent when I extrapolate. And here we have the data from exactly the same thing. Here we have some new things. Here. Qu'est-ce qu'on a de nouveau? In the sum, we have only one flow in aggregated one. Now we have, for la masse salariale, we have to split it for many, many households. And we need a key, on a besoin d'une clé, to allocate for each household a part of the salaries, a part of the capital, a part of the transfer, and a part of, and what we did here, it's a very simple situation. We can do better, is to give the value, what we observed in the survey, or after adjustment for the value. Just to give you the example here, somewhere, just to give you exactly the calcul we did. Here we propose here. This is the theta salaire, is the part of salaries which go to households. Here, look here. Yalla, someone please can interpret that just to participate with me. What we have here. Can you interpret this? Someone of you. Est-ce que quelqu'un peut m'interpréter ça? Il y a quelqu'un qui lève la main, non? Personne? Je le fais. Alors, écoutez-moi. Ce qu'on est en train de faire, what we are doing, yes, someone, no? What we are doing is, because we have the total of salaries, a new value of salaries here, but we want to know what is the part for each household. This is observed things. The hypothesis here is to tell for each household, we have the part is what we observed. Just to give you an example, suppose for a household we have 0.003. This is the part he has from the global sum of salaries. And here, the part of the capital, here, the part of the, it's a small hypothesis here. is only to split the total of the flow between households at column and line in observed situation as we observed in the reference. This is the hypothesis here. If we have better situation, we can put it at this level. Now, this is the new thing at this level. Other than that, I think there is no real change on this. But here we have to look this. Here we have many situations because we have many households. I give you just an example. It's exactly what Shahir presented yesterday. Just I give you, and I will ask you to interpret this part, for example. Suppose we have to interpret this equation because it's a new one. This is the consumption of each household in each goods. The consumption of goods TR by the households R. You can see what it's a matrix, right? It's a matrix because we have 3 goods and we have 4,000 households. This is a matrix. So the model is very big. When we are solving a microsimulation model with full integrated approach, we have many variables. This is what we have to solve now. This is the model. There is no other modification. I add his objective function if we want to use it. It's exactly what we discussed yesterday because we want to use a MCP, a CNS, or other solver here. Now I put the simulation or without simulation for this, and they have to solve. Now we have to solve the model without any simulation, calibrated in the global situation, and we have to solve it. I run it. It takes more time than a global model, but he's found the solution. But now, if we go and to look for the statistic of the model, look at Shahir and Dorothy also tells you that we cannot solve a model if it is not a square model. Look at single variable and single equations. Look at why we have that. Because we are in a microsimulation resolution. We have many equations and many variables as looking for all households and all integrated in our equations, in our model. This is why we need to have a solver. We have to use a license for a solver. And we can use any of these solvers. Yesterday, I think there is a question about that. In this situation, I am using Connopt to solve the model. But I can use Minos, I can use IPO, I can use MCP, CNS, exactly what used yesterday for the model. So, to summarize for this one, when we have our aggregate model constructed before, we can change it to put it in a microsimulation form. We don't need the introduction of sets because it's done before in the calibration situation when we are calculating for the new value. We change légèrement, we change in the marginal transformation of the model to integrate some features because we add some characteristic of households because it's specific to each household. And after that, just to solve, but we are in retry. We are using the results of we have here. There is another possibility to use $include for some of you know $include and restart. Now we solve the model we are sure it's consistent, and after that we solve it for the reference situation, as if in a dynamic situation, like in a business as usual situation, but we can solve it for the micro simulation. I will do that for the micro simulation just to show you the difference. Now, for this one, just to show you for the reference year, I will solve it. Look here, exclude in dollar. Here we have the situation in the reference. I put the situation here, okay? And I solve, there is no simulation. I solve my model for the reference situation. I can see the situation for all variables I want to look for here, and I do it in a GDX file. So I have to open the GDX file. Its results is here. Okay. Here we have the situation in the reference year, the situation, past situations. We can see for, I don't know which variable we are looking for. I can see for the, I don't know, consumption of a particular good or a salaries or other. We can see, qu'est-ce qu'on peut regarder? Je sais pas. Which variable we want to see. After a resolution, we can see for consumptions, new, je crois la variable c'est N, new consumption of agricultural goods. This is the new consumption for each household.
Trop petit.
C'est trop petit. C'est trop petit, c'est trop petit, c'est trop petit. I don't know how can. Je sais pas comment. Just I want to put it more maxima. No, je sais pas comment. Just to be here, if you can see here, I have the variable for all households in my survey, all. So I can do my my analysis. Now I can do the same thing after simulation. So I can do exactly the simulation we did before. Je sais pas, 0.5. And here 1.1. We are in a microsimulation and we are simulating a shock. The number of variables we have to find is very big. It's exactly the same in a reference year, and we will have a new value. We have now, after simulation, the new situation after simulation. And I can compare in the reference year for all variables, and after that, particularly for the household side, to do my poverty analysis, my inequality analysis, and I can export the data I can export all my results to Stata, and I can do all I want to do here. This is the first possibility we can do here. The last thing I come back to explain it, what we did here, it was I chose to change the flow only. We can do that on the I chose to do it for this model, for the general one. I changed the flow and the extrapolation weight. So I have to solve this model. And in this one, I have the new equations. I have the equation where they have G for the global one. And here, I stop the resolution of the when we have inflow, but I will solve the biggest one when we have more than this variable, because I am solving for the big model where the weight are changed with flow. in the first one, okay? It will take more time. Here we have a feasible solution. So we must be optimistic that he wants to find a solution. Now we are solving for the new extrapolation weight for each household and for all flow we did before. Clearly, the solution will be different because we have more space, more degree of freedom, and it's more interesting for us to have that because the variable, the errors cannot be supported only by the flow. It can be reparted between the flow and the extrapolation weight. When waiting to the solution, if you have any question for this, because we have maybe 7 minutes, 10 minutes to answer some questions. Shire.
I have a question about when you talked about the budget constraint for each household.
Yes.
That must be respected.
Yes.
For those 4,000,
yes.
etc.
Yes.
Do we do that before integrating we check like for this equality before integrating the data, or is the program in GAMS that will do it? And will correct if there is some...
No, the GAMS will do it. The GAMS will find the solution satisfying this. Generally, the data you have don't satisfy this condition. It's Asma, les données de l'enquête, the data from the survey generally do not satisfy this condition. We ask GAMS to find exactly the solution where the budget constraint is satisfied for each household. It's not from the input data. This is your question? Okay. Donc, on n'est pas en train de regarder. Si vous prenez l'enquête, vous trouverez toujours qu'il y a un écart entre revenus et dépenses des ménages. C'est toujours impossible. Mais nous, on ne peut pas faire de la modélisation en équilibre général microsimulé s'il y a ces écarts. Qu'est-ce que la méthode fait? Il corrige les flux de telle sorte que chaque cellule soit respectée lorsque j'extrapole, et chaque ménage doit avoir ressources égales emploi. On lui demande beaucoup, en fait. Et c'est ça ce qu'on est en train de faire. I don't know if you understand, Asma.
Parfaitement, oui.
Merci. Autre question? Je ne sais pas où est-ce qu'on a la solution? Il a fini? It is still working, you see, because it's a big model. This is why in the theoretical presentation, I told you that if you want to do microsimulation, you have to use a solver. Sometimes there is a constraint when you want to use a microsimulation because we have that limit or constraint on the numerical aspects. Here we are, you see, it's more 3 or 4 minutes and it's not finished because it's a big model. I hope he has to finish before the finish. We see the result. Share. Any question?
Let's suppose we don't have a license for those solvers, those like strong solvers. What's the limit for the limit?
For the demo for the demo license?
Yes.
Yeah, demo license I think is less than I don't know, 50 households ou quelque chose comme ça, 20, 30, 50. Je ne l'ai jamais eu puisque moi, nous avons des licences et donc je ne peux pas répondre à combien. Je ne sais pas. Et puis, ça dépend aussi du nombre de biens, puisque, par exemple, dans un modèle, nous avons utilisé, je ne sais pas moi, 39 biens. We have only 3 goods. In our situation, we use a very big situation, and it's more. This is that. I don't know why. I don't know what is the limit of that.
Mais supposons qu'on ne fait pas de la micro-simulation, qu'on veut juste... On va
Exter,
juste...
Exter, le modèle que Shahir vous a présenté hier, Exter, que je vous ai présenté aujourd'hui, où il y a un seul ménage, ça devrait passer dans, dans le mode démo. Est-ce que c'est ça votre question?
Oui, et avec quand vous avez utilisé des groupes, ça veut dire si on limite un découpage,
Et
une
vous limitez le nombre
désagrégation
de
en
groupes,
groupe,
ça
ouais,
devrait passer. Ça devrait passer.
devrait
Je
passer
crois que
aussi.
vous allez avoir quelque chose comme 100 variables, 100 équations, quelque chose comme ça, ça peut passer, je crois.
Parfait.
Donc,
Merci.
vous voyez un peu ce que ça fait comme simulation, et ça prend beaucoup de temps, mais on sait que ça doit résoudre. On sait puisqu'on l'a essayé avec l'autre. Donc, le modèle est bien carré, tout ça. Just to give you that. Yes, Shahir, other questions?
Any other questions, given that we're almost at the end of the lecture? No questions? I think what's really interesting in the microsimulation here is how I think two main things, as Tuhami explained, how we make the coherence between the macro data and the micro data. This is the demanding part of the modeling, and the second part how consequently we are able to implement the macro shock at a very detailed level. And as you can see, also given that GAMS is running now, yesterday we had like 2 or 3 iterations, maximum 10 iterations until the model found a new equilibrium. But now it's still running and we are almost 300 iterations. Why? Because it's running for all the at the macro and the micro level. Now we have the micro data that is embedded in the CGE model. So I don't know if you want to add something else to Hemi or Dorothée.
Dorothy?
No,
You have something to add?
no, no, no.
No, elle dit non. No, just I hope you understand the object of what we are doing in microsimulation, particularly in full integrated microsimulation, why we did that, and how it is easy or not easy to do that. It's yours to invest on that if you need to use that. And if there is any help you ask it for, we are here. You can send a message to Shahir, to other colleagues, and we can interact if you are interested on, particularly on that.
Yes, I have maybe one thing, because the full integrated version or approach is maybe the more difficult also. It's why we find today more papers, articles with other approach. It's very demanding, as you see, but it's interesting when it's work, but it's very demanding, and it's why in the literature this approach is less applied today.
But it assures the coherence between the macro and micro level. This is the advantage. We stop here, Shahir?
Yes. So any questions, everyone? Anything that's not clear? Any queries? So given that the model is running, I think we, in all cases, now you understand the rationale of what we aim at having in the microsimulation model. Perhaps a couple of concluding remarks. Clearly, in this course that was just 12 hours with Dorothée and Tuhami, we covered the content of a course that could be done over a whole year between the static models, dynamic models, microsimulations, but it was a crash course just to show you to what extent CGE models are relevant. They can be implemented to cover a wide range of issues at both the macro and the micro level. They are theory-based, so because in general, and I'm sure that Tuhami and Dorothée, they share with me this view, those who work on CGE models, we are always accused of working with black box, but I always say that those who don't understand CGE models, they just accuse us of that, while CGE models are really theory-based on the macro theory, on the micro theory, So the more we understand the theory, macro and micro behind, the more it will be straightforward and not really a black box. But it can be a black box if you don't understand the theory and if you just press on the button to get some results. So that's why, even though what we've done was a lot for 4 days, but like any other empirical technique, it's a learning by doing process. We just gave you the introduction. We will send you the material. Then you can deepen your knowledge from different sources on internet, especially PEP, that is a wealth of information for CGE modeling. Personally, I learned CGE models with the book of Bernardo Calvi that I was talking about yesterday, and then with a trial and error, you can just develop your own model. A couple of logistic points. So 4 main points. First, after next week, you will receive a folder, a Google Drive link from Ramaj with the material that we use for your private use. It will include the examples of the codes, the slides, and further readings for those who need. Second, Ramaj also will send you an evaluation form that is very important for us because it helps us improve the training workshop and see what can be improved, what can still, what we have to keep as it is without changing, and so on. So please do this evaluation. Those who also fulfilled the attendance requirement will receive a certificate of attendance from Ramaj. And last but not least, I'm very happy that we did this course with Tuhami and Dorothée. This time it was really enriching, and I always say that we always learn something new whenever we attend such workshops, even if we master those techniques. But I personally learned a lot. And at the end, I would like to thank all of you. I know that online courses are not very friendly, but it's the second best. So thank you all for your participation, your attendance, and your interest. And special thanks also for Ramaj and Namis for all the support, the admin support, the technical support, because without them, this course would have never been successful. So thank you all. Have a nice end of week and have a nice weekend if you already started your weekend. And have a nice summer break as well.